Hello everyone. For this topic here, I will now show you the relationship between resistance and the other parameters that affect the resistance of the conductor. Now, what you can see on the screen here is that there are three factors that affect the resistance of the conductor. First is the length of the conductor. So as you seen in the diagram on the right hand side, this is the length that we are referring to. Okay, so for this discussion purpose, I denote the length with a capital L. Right, for the other three, this is the length, this is another length, and this another length. Right, so for this, refer to the length of the conductor. How about the cross-sectional area? The cross-sectional area will refer to this. I'm going to color in orange. Right, that's the cross-sectional area. Here, this is the orange part, and this is the orange part. And here. So how do we know which is the cross-sectional area and which is the length? You first have to identify the current flow. Which is the direction of the current flow? Look at the current flow first. Okay. So in this illustration here, the current flows through the cross-sectional area, and hence the part colored in orange is the cross-sectional area. Right, the part in orange is cross-sectional area, and the part I highlighted in red refers to the length. Now, what if I give you another illustration? I give you a cube. Sorry, rectangular block. All right, rectangular block, and the current now flows here. This is the current flow. Right. So if this is the current flow, then this is the cross-sectional area. And this will be the length of the conductor. So how the current flow basically depends on how you connect up the circuit, as we covered earlier in the first part under terminology. So three factors: length of conductor, cross-sectional area of the conductor, and finally the material of the conductor. You have learned in lower secondary, that electrical properties is one of the properties of matter is the electrical properties. But you learn generically in a lower sec that all metals are good conductors. So for this topic, we're going to cover that there are many types of conductors around, and each conductor is able to conduct electrical current differently. So for the material of conductor, I'll introduce this term called resistivity towards the end of this video. So for this image here, we're going to discuss how the length of conductor affect the resistance of the conductor. Now, if you look at the diagram given on the right, Okay, this is a shorter length and this is a longer length. So let's go by this analogy. Is it easier for the current to flow through a shorter length or a longer length? Likewise, is it easier for you to run a shorter distance or a longer distance? So I think the answer is quite obvious, right? It's easier for you to run a shorter distance, and therefore it's easier for the electric current to flow through a shorter length of conductor, and therefore when the length decrease, resistance also decrease, and when the length increase, the resistance also increase. How about the cross-sectional area of the conductor? So let me highlight again. This is the cross-sectional area and this is the cross-sectional area. Okay, let's have this analogy, all right? When the pathway is very wide, is it easier for people to walk through the pathway, or is it easier for people to walk through a narrow pathway? And I believe the answer is very obvious, right? If the pathway is very narrow, it's more difficult for people to walk through compared to a very wide pathway. Likewise, if the cross-sectional area is small, the current is going to face greater resistance. And if the cross-sectional area is big, the current is going to face a lower resistance. And finally, the third factor, the material of the conductor. Right, the material of the conductor, what we refer to here is the resistivity. Okay, and over here we learn the word resistivity. And I want to caution everyone here to avoid using conductivity. Do not use this word. Right? Do not use this word. This is a common mistake by students. Okay, I guess it's because they are able to associate the word conductor, right? But do not use these terms loosely unless you're familiar with its definition. So in this case, I will highly recommend you use the term resistivity. Now you don't have to know the exact definition of the resistivity, you just know that it's a property of a material. It's just a property, and the SI unit is ohm meter. It feels a bit strange, right? An electrical unit and a physical dimension unit put together, right? But well, just accept it. Now, we're not going to discuss the details of experiment that shows the relationship between resistance, length, cross-sectional area, and resistivity. That will be explored further in your higher studies. For now, we'll just introduce to you the formula R equals rho L over A, where rho refers to the resistivity of the conductor. You should be familiar with this symbol rho because back in mass weight density, you're actually familiar with this symbol rho, alright? So generally, rho is used to represent properties of materials in physics. So in this case, this rho represents the resistivity of the conductor, and SI unit is ohm meter. Length refers to the length of L refers to the length of conductor, A refers to cross-sectional area, and R refers to the resistance. Hence, we have R equals rho L over A. So another way to look at it is your resistance, sorry, your resistance is directly proportional to L, provided resistivity and cross-sectional area are constant. You also can look at it this way. Resistance is inversely proportional to cross-sectional area, provided resistivity and length are constant. And to express it mathematically, I think by now you all should know this. I think, okay? R is inversely proportional to A, and for the above, R is inversely proportional to L. So this is it for resistivity.